you so much for coming to my talk. My name is Lydia Hallie. I'm a staff developer advocate at Vercel, and I'm here today to talk about rendering patterns. Now, I'm not here to talk bad about certain patterns and praise others. I'm just here to talk about the common patterns that we see nowadays and their trade-offs for specific use cases. Building on the web has never been more powerful than it is in 2022, but it can feel pretty overwhelming at times. Ideally, we just want to develop, preview, ship, impress our users, and change the world with our revolutionary ideas. Unfortunately, in most cases, it doesn't quite end up this way. We might accidentally end up with really long build times, frustrated users because the website's load real slow or has a jumpy UI, and we might end up with a huge server bill at the end of the month for a project that didn't even gain traction. Since our user experience is so bad, our website never got a great SEO, so most people don't even know this website exists. Although our idea might have changed the world, the way that we architected our project prevented this from ever happening. So what can we do about this? We have to start caring about using the right rendering patterns. Knowing how to apply these techniques can massively improve your app's performance, giving you a great product to share with the world. Now, usually when we talk about performance, we think about optimizing for the core web vitals. These are a set of very useful measurements that tell us how well our website performs. For example, the time to first byte measures the time it takes for the server to respond with the initial data to make sure that we don't have long server response times. And the first contentful paint measures how quickly your users see useful content on their screen for the first time. If we want to have a website with a great user experience and a great SEO, we have to start caring about optimizing for these measurements. But that's not all, because we also want to have the best developer experience. We want a project with short build times to be able to quickly iterate, low server costs so we don't go bankrupt, and no scalability issues further down the line when our website goes viral. Although it seems like a lot to keep in mind, using the right rendering technique can really help you out to create a great user and developer experience. But how do you know which rendering technique makes the most sense for your application? Or if you're using Vercel, you can even pick a rendering technique on a per-page basis. So which one makes the most sense for that specific page? Spending 1 minute on Google or on tech Twitter can already feel pretty overwhelming with all the new terms, abbreviations, and the latest trendy ways to render data and people's opinion on them. All patterns out there have their use case. There's not one pattern that's better than the others, as long as you know their trade-offs. So let's talk about the problems that the patterns are trying to solve to make sure that you can optimize your website and have a great impact on the world. First, let's talk about a pattern that may seem very basic and straightforward, namely static rendering. Static rendering is a popular pattern as it comes with so many performance benefits. And although it might seem simple, there are many variations to static rendering to serve a lot of different use cases. Static generation can be an extremely performant pattern as the entire HTML gets generated at build time. Since the files are static, they're also easily cacheable by a CDN. On Vercel, all static assets are automatically cached by our Edge network, meaning that once a user has requested the page from the origin server once, the edge that was closest to that user's location will cache this response. So on subsequent requests within this region, the request doesn't have to travel all the way to the origin server. It can just simply use the cached response. Let's take a look at this landing page of this fake demo real estate website. This page is absolutely perfect for static rendering, as it just shows the same data for everyone globally. We aren't fetching any data or showing any personalized components. When we deploy this, in this case to Vercel, the HTML for the pages get generated and persisted to static storage. When a user visits the website, a request is made to the server. The server can quickly return the pre-generated HTML to the client, and as it gets returned, the edge location closest to the user caches this response. The browser renders the HTML and optionally requests a JavaScript bundle to hydrate the page, meaning making the HTML elements interactive. From a performance perspective, this is a great approach. We have an extremely quick time to first byte, since the server already contains the pre-generated HTML. and the browser can quickly render something to the screen, resulting in a really fast first contentful paint and largest contentful paint. We also don't have to worry about a jumpy UI since we're not dynamically loading components. Plain static rendering is great for your core web vitals, especially in combination with a CDN. However, in most cases, we'll probably want to show some dynamic data. Say that instead of showing some services here, we actually want to show some recent listings. Now, we could just hard code that data right in the page, but in reality, we'll probably want to use some data provider to get our listings from. One approach we can take here is to use static rendering in combination with client-side fetching. We could simply statically render the page like we did before and fetch the data on the client as soon as the page has loaded. We could still use a similar approach to what we did before and fetch the data on the client with, for example, SWR. While the data is being fetched, we'll show a skeleton component. To fetch the data, we need to create a custom API route. Now, when the user requests the page, the server again quickly returns the pre-generated HTML, and the user initially sees a skeleton UI. The HTML with the skeleton UI is again cached by the edge network. After parsing and rendering the initial content, the browser fetches the data from the API route, after which the listings are visible to us. And for simplicity, I'm not including the hydration call in this example, but that's also a step. Although using static rendering and fetching client-side gives us a great time to first byte and first contentful paint, the largest contentful paint is not as good as it used to be, since we have to wait for the API route to return data in order to show the listings. We might also run into layout shifts, which can happen if our skeleton component doesn't match with the content that eventually gets rendered after receiving the data. Since we're calling the API routes on every page request, we can also run into higher server costs as we pay for every execution. When you use Next.js, you can actually choose between a few more static approaches that really improve the performance of your app when working with dynamic data. The first approach is to use the GetStaticProps method. This method runs server-side at build time, meaning that we can directly call our data provider within this method. If your data is available at build time, this can be a really good solution to add dynamic data to a static page. Since the GetStaticProps method runs server-side, we no longer have to deal with custom API routes to fetch the data from. We can do this directly within this method. We also no longer have to show a skeleton component, as there will never be a loading state. The generated HTML now already contains the fetched data. When we build the project, the data provider gets called and the return data gets passed to the generated HTML. Now, when we request a page, we again fetch the HTML from the server, the response get cached and rendered to the screen, and then the client optionally requests the JavaScript bundle to hydrate the page. The network and main thread are identical to what we saw before when we were just statically rendering the content without injecting any data at build time. So from a user perspective, we again get a great performance. However, from a developer perspective, you can quickly run into some issues. Imagine if we statically built hundreds of pages, which can easily happen on a blog or an e-commerce website, and we're calling the GetStaticProps method for all these pages. This can result in really long build times. And if you're using an external API, you can even hit the request limit pretty fast. Or you might get charged a lot of money if they charge per request. Another issue is that we're only renewing the data at build time, meaning we'd have to redeploy the website to update the content. Luckily, we can use incremental static regeneration to solve our build time and dynamic data issues. With ISR, we can decide to only pre-render certain pages and render the other pages on demand when the user requests it, resulting in much shorter build times. It also allows us to automatically invalidate the cache and regenerate the page after a certain interval. Imagine if we wanted to be able to show individual listings as well, and pre-render these pages to get great performance when a user clicks on a listing. Using Next.js, we can have dynamic paths in the combination with getStaticPath to tell Next.js which pages to pre-generate based on their query parameter. In this case, we're fetching all listings and pre-generating the pages for each and every one of them. Now, if we had thousands of listings, this would take a really long time to finish. Instead, we can tell Next.js to only pre-generate a subset of all the pages, and render a fallback while the listing page is being generated on demand when the user actually requests the page. The pre-generated pages behave the exact same, but if a user requests a page that hasn't been generated yet, it gets generated on demand, after which it automatically gets cached by the edge. This means that only the first user within a region might have a worse experience as the page still needs to be generated, but everyone else can benefit from getting a fast, cached response. Our long build times have been solved, but we still don't want to have to redeploy the landing page every time to renew the data with the latest listings. Instead of only renewing the data at build time, we can automatically invalidate the cache and regenerate the page in the background on a certain interval. We can use this by adding a revalidate field to the return object of GetStaticProps. Now, when a user requests a stale page, meaning a page that has been cached for longer than the specified number of seconds, the user first gets to see that stale page. But a page regeneration is triggered while the user is still seeing the stale page. Now, once the page has been generated in the background, the cache gets invalidated and updated with the latest page. Now, when the user requests the page again, they'll actually see the updated content. With incremental static regeneration, we can show dynamic content by automatically revalidating the page every number of seconds. Although this is already a huge improvement to what we had before, we can run into some issues here. It's likely that our content doesn't update every number of seconds, which would mean that we're unnecessarily regenerating the page and invalidating the cache every number of seconds, even though the data hasn't updated. Every time, we're also invoking our serverless functions, which could result in higher server costs. The best option here is to use on-demand incremental static regeneration. On-demand ISR allows us to use ISR, but instead of regenerating on a certain interval, we can trigger a regeneration manually. Instead of relying on the revalidate field, we can manually revalidate pages in API routes based on an incoming request. For example, we can listen to an incoming webhook event that tells us when new data has been added to our data provider. When we invoke the revalidate method, the page on the specified path automatically gets regenerated. Another huge benefit of using on-demand ISR over regular ISR is the fact that the newly regenerated page gets distributed throughout the entire edge network. With regular ISR, the return response only gets cached in the regions where users sent the request from. However, with on-demand ISR, users from all over the world will automatically hit the edge cache without ever seeing stale content. We also don't have to worry about unnecessarily invoking a serverless function every number of seconds, making it a much cheaper pattern to use. On-demand ISR gives us all the performance benefits combined with a great developer experience. We don't have to worry about the high server cost as long as we don't trigger the revalidation too often. And we can bring a great performance to all users all over the world in combination with the edge cache. Static generation is an amazing pattern that can be used for tons of use cases, especially in combination with ISR. We can have an incredibly fast and dynamic website, and our website is also always online since there's always a cached version available. However, there's also tons of use cases where static isn't the best way to go. For example, for highly dynamic, personalized pages that are different for every user. In that case, we might want to use server-side rendering. Whereas we generated the HTML at build time using static generation, with server-side rendering, we generated on every request. This can be a great approach for pages that contain highly personalized data. For example, data based on a user cookie or just generally any data that's contained within the user's request. It's also really good for pages that should be render blocking, for example, based on user authentication. An example of a highly dynamic page that requires a user cookie is a dashboard. This dashboard is only shown when a user is authenticated, and it shows mainly user-specific data. With Next.js, we can use server rendering on a page using the getServerSideProps method. This method runs server-side on every request and eventually passes the return data to the page in order to generate the HTML. When a user requests the page, the getServerSideProps method runs, after which the page gets generated and sent to the client. The client can quickly render this HTML and can send an additional request to the server to fetch the JavaScript for hydration. The generated pages are unique to every request, meaning they aren't automatically cached by our CDN. And although this is the expected behavior, there is just more to take into consideration if you want to get a good performance for every request. When we look at the network in the main thread, it looks pretty similar to what we saw with static rendering. The first contentful paint is basically equal to the largest contentful paint, and we can easily avoid layout shift, as we're not dynamically rendering content. However, when comparing static rendering and server rendering, you can see that the time to first byte can be very short when we statically render data since it's already pre-generated. It can be a lot longer when we're server rendering as the page needs to be generated on demand. Although server rendering is a great method when you want to render highly personalized data, there are some things to take into consideration to achieve a great user experience. We might also run into way higher server costs, which in some cases is completely worth it, but there are a few things that you can do as a user to optimize your SSR performance. First, we have to make sure that the GetServerSideProps method doesn't run too long. The page regeneration won't start until this method has resolved with data that gets passed to the page. One thing to keep in mind, and that's often the cause of a long GetServerSideProps execution, is the time it takes to fetch data from your database. If your serverless function is deployed in San Francisco, but your database is deployed in Tokyo, it can take a while to establish a connection and get the data. Instead, consider moving your database to the same region as your serverless function to ensure that your database queries can be a lot faster. Next, you might improve your performance a bit by adding caching headers to the responses. However, if you find yourself doing that, your page might work even better if you used ISR. Besides not having to manually take care of revalidation, the recomputed page will also be shared globally as opposed to one single region. ISR also ensures that your website is always online, since there will always be a cached version available, whereas SSR is dependent on the availability of the Lambda. So if a region goes down, so does your website. However, since ISR doesn't allow you to use request-based data, SSR is often still definitely the way to go. Next is something that's not as easy to do, namely upgrading the server hardware to get faster responses. When you deploy to Vercel, we use serverless functions to server render your pages. Although serverless functions come with so many benefits, such as only having to pay for what you use, there are a few major limitations. A common issue is the long cold boot, meaning the time it takes to start up the Lambda, and the slow connection to databases. It's also not great to have to call a serverless function all the way on the West Coast if you're located on the other side of the planet. Server rendering is still an extremely powerful and commonly used rendering pattern, and we want to make this a lot better. At Vercel, we're currently exploring Edge SSR, which enables users to server render from all regions and experience a near-zero cold boot. Another huge benefit of Edge SSR is the fact that the Edge runtime also allows for HTTP streaming. With serverless functions, we have to generate the entire page server side and wait for the entire JavaScript bundle to be loaded and parsed on the client before hydration could begin. With Edge SSR, we could stream parts of the documents as soon as they're ready and hydrate these components granularly. This means that users no longer have to wait for a longer time before they can actually see anything on the screen, as the components just stream in one by one. Instead of having to wait for a longer initial call to the server before the client receives the first pieces of data, the data now gets streamed to the client as soon as it's ready, allowing the browser to granularly render and hydrate each component. The smaller components now no longer have to wait for the larger components to be ready. Streaming SSR also enables React Server components. Now, I'm not going to go into the nitty-gritty details of React Server components, but the combination of Edge SSR with React Server components can allow us to have a beautiful hybrid between static and server rendering. React Server components allow us to partially render React components on the server, which is especially useful for components that require large dependencies, as we no longer have to download these dependencies on the client. For example, if we wanted to show the landing page again, but this time we wanted to show region-specific listings to the user, the vast majority of the page only contains static data. It's just the listings that require request-based data. Instead of having to server render the entire page, we can now choose to only render the listing component server side and the rest client side, whereas we initially had to server render the entire page to achieve this behavior. We can now get the great performance of static with the dynamic benefits of SSR. Although there are many patterns to choose from, which may feel overwhelming, knowing which patterns makes the most sense for your use case can give your application huge performance benefits. On Vercel, you can opt into these techniques on a per-page basis, making it extremely easy to scale without running into performance issues when your application grows. Static and server rendering both have their place in the world, and we're working on a future where we can create highly personalized websites with a great performance. The web is extremely powerful and it's only getting better with an edge-first approach. Thank you so much for coming to my talk and have fun coding.